Sorry I have to be gone today. Hopefully the sub has given you 5.1 Graphing Functions notes. If not, pause the video, ask for the notes to be distributed, then resume the video. Today I'm going to go over some of the notes, not all of it. This is a review from Algebra 1, but it's been a really long time. Quadratic functions, they always have a degree 2, so it's going to be x squared somewhere in the problem. And it also is a graph of a parabola. We have a parent function, which over here I like to call the OG function. It's the original graph, or the parent function. The parent function is going to be y equals x squared. All of your quadratic graphs will look like this shape. They just might be shifted up, down, left, right, maybe wider or more narrow. So for this graph, I'm going to create a t-table. If I were to plug in these values, negative 2 squared, that means negative 2 times negative 2, is positive 4. So negative 2, 4. And then if I plug in negative 1 squared, negative 1 times negative 1 is positive 1. If I plug in 0, I get 0. So it's at the origin. If I plug in positive 1 squared, I get 1. Plug in 2 squared is also 4. So it looks like this shape right here. It is not a V, that is absolute value. This graph is a U-shaped graph. So here's your OG graph, your original graph. And it looks like a U. Should be smooth, not shaky like that one. So everything is based off this parent function. We have some important things we could talk about. The vertex is either going to be the highest point or the lowest point. So my vertex on my parent function is at 0, 0. So that's either the lowest or the highest point. If you can figure out where the vertex is, you'll know exactly how this graph is shifted up, down, left, or right. Your axis of symmetry, basically that is a vertical line that cuts your graph exactly in half. If I go too fast, you know you can always pause and resume the video or rewatch it. So this is a vertical line, and it's going to cut your graph exactly in half, which happens to go through your vertex. So it's the vertical line through the vertex. So on this one, all vertical lines are x equals, so that would be x equals 0. Some other things we can talk about is this is standard form. Of a quadratic. Standard form means that you're going to have a number in front of x squared, it could just be 1, plus a number in front of x, plus a number by itself, a constant, so a, b, and c. These values tell you some important information about your graph. The a is going to tell you multiple things. It's going to tell you if it opens up or down. It's also going to tell you if it's wide or narrow. If it's just a 1, it's not going to be wide or narrow. It's going to be just the same width as that one. B is going to tell you some information about your vertex. A also helps you find the vertex, but B is very important. C tells you your y-intercept. So you're guaranteed to find at least one point on your graph just staring at the equation in standard form. You know, that last number that doesn't have a variable with it is your y-intercept. So if we look at this first example here, we know 6 is the y-intercept immediately. So if I come over to my graph, I know I have that point right there at 6. Some things that we need to talk about are how to find your vertex. So up here, maybe to the side, vertex, you can write x equals negative b over 2a. Instead of saying negative b, you could say opposite of b. So we are going to go find a, b, and c given this standard form of the very first example. So a is 2, b is negative 8, and c is 6. The first thing I think that's the most important is to find your vertex. So x equals negative b over 2 times a. Negative b, I guess I could have said opposite of b, so what's the opposite of negative 8? We could think negative 8, so that would be a positive 8 over 2 times 2, because my a is 2. That's 8 divided by 4, so my vertex is at x equals 2. So I'm going to come over here to x equals 2, and I'm going to draw a dashed line. That is my vertex at x equals 2. Scoot that up. That is my axis of symmetry. Also, I know that my vertex is somewhere on that. If I were to make a t-table, I'm going to pick 2 points higher and 2 points lower than that value that I found for my vertex. So I immediately put 2 in the middle of all of that. If I were to come up with 2 points higher, that would be a 3 and a 4, and 2 points lower. Now I'm going to plug those in to my x over here. So if I were to plug in 0, I would have 2 times 0 squared minus 8 times 0 plus 6. All I'm doing is taking out the x and putting in 0. Make your calculator do this. That wipes that out, so I get 6. Make your calculator do the next one as well. 2 times 1 squared minus 8 times 1 plus 6. If you did that, you could plug in and you would find you'd have 2 minus 8, which is negative 6, plus 6, you get 0. I could plug in the 2. If I plug in 2 to my calculator, I will get negative 2. That's my vertex, 2, negative 2. If I plug in, if I plug in 3, and I've color-coded these on purpose because your calculator should tell you this is also 0. You should have some things lining up here, some symmetry should be happening. 2 times 4 squared minus 8 times 4 plus 6 is 6. So if I go plot these points, 0, 6, 4, 6, you'll see the symmetry. 1, 0, 3, 0. And then 2, negative 2. My graph should make a nice U-shaped, not a V, a U. So that's the very first one. Please stop this video, rewind if you need to watch anything, and go to the next video.